I want you to evaluate 2 sine of pi over 12 cos of pi over 12. Now, depending on how you would think about doing this, this could be a 7-mark question. Because if you think about pi over 12, we learned that the other day, right? The pi over 12 questions, you used your alpha plus beta formulas. You had to figure out something that added or subtracted to get pi over 12. And usually a single pi over 12 question is worth 3 marks. But this one, can you see it has 2 of them in it? It would have a sine of pi over 12 and a cos of pi over 12. So figuring out sine of pi over 12 using our pi over 12 methods would be worth 3 marks. Figuring out cos of pi over 12 using our pi over 12 methods would be another 3 marks. And then there would be a mark for just putting it all together. But this is a question that has been on final exams, and it's only worth 2 marks. So there must be a much faster way to do it. So you're saying that this whole thing is equal to sine of 2 pi over 12? Why? Because there's another formula. So again, if you recognize this blue thing as 2 sine alpha cos alpha, which we have on our formulas up here on the wall, and you also have on your formula sheet, if you recognize that, then you can change the right-hand side to the left-hand side. And you notice that alpha is pi over 12, so I can write it as sine of 2 times pi over 12. Now that is going to be a lot faster than using your pi over 12 methods. However, when you get to an exam and you're nervous, you might just go with whatever you see first. And if you see the pi over 12, that might trigger you to think, oh, it's a pi over 12 question. I know how to do that, and jump right in. So we really want to have our formulas memorized so we can recognize them. So when you see 2 sine pi over 12 cos pi over 12, you're like, hey, that's one of my formulas. You should also be thinking, hey, I could use pi over 12, but what else is there? And then when I have this, what does this reduce to if you simplify it? Sine of pi over 6, which is 1/2. Done. That's a lot better than doing the pi over 12 method, and a lot quicker. So in example 2, we've got a bunch of these. And they say to write each expression as a single trig ratio, then evaluate where possible. So in the first one, we've got cos squared pi over 4 minus sine squared pi over 4. What is that equal to? Right. We can look at this as this is our alpha and cos squared minus sine squared. Don't get it confused with cos squared plus sine squared. If it was a plus sign, you'd say right away it's equal to 1. But it's a minus sign. And there is a formula that has cos squared minus sine squared. If the angles are the same, it's equal to cos 2 alpha. So you'd get cos of 2 times pi over 4. What does that simplify to? Cos of pi over 2. And what is cos of pi over 2? 0. Now, this question in particular, if you were asked to evaluate, you might not use this formula whatsoever. Because is pi over 4 on your pi plate? What is cos of pi over 4? Right, so you could evaluate, well, if cos of pi over 4 is root 2 over 2, what is cos squared of pi over 4? Root 2 over 2 squared. Does that make sense? If cos of pi over 4 is root 2 over 2, then cos squared would be root 2 over 2 times root 2 over 2, which is root 2 over 2 squared. Awesome, thank you. And if sine of pi over 4 is root 2 over 2, then sine squared of pi over 4 would be root 2 over 2 over root 2 over 2 times root 2 over 2, or root 2 over 2 squared. Yeah. And if you subtracted those, you would get 0. So if you were just asked to evaluate this, probably most of you would choose the blue method here and just say, that's on my pie plate, I know the values, I can figure it out. But sometimes, and what will often happen on an exam, is they will give you values that are like pi over 8. Is pi over 8 on our pie plate? No. But can you see that if I used pi over 8, that this becomes pi over 4, and cos of pi over 4 will be root 2 over 2. I think that would be a better question to come up on a quiz or exam, because you would look at it originally and say, I can't solve this. So it would force you to use one of your formulas. Part B. Now, you're not going to have your formulas completely memorized. Some of you might completely memorize them. Most of you will have them mostly memorized. And by mostly memorized, you'll say, oh, there's a fraction with a whole bunch of tans. I've seen a tan fraction before with a whole bunch of tans. I should look at my formula sheet, right? And then when you look at your formula sheet and you look around, you want to say, does this match up with any of them? Because we have 3 lots of tan fraction formulas. It looks really close to the tan 2a one. So I'll just write the tan 2 alpha one down. 2 tan alpha. Oh, 1 minus tan squared alpha. Oh, it's so close, right? And yes, exactly. If you take this and factor out a negative on the bottom, now some things about fractions. Now I have a negative on the bottom. Are you aware with a fraction that a negative on the top of a fraction is the same as a negative on the bottom of the fraction, is the same as a negative out in front of the fraction? So now that we have a negative on the bottom of the fraction, we can say this really is the same as a negative out in front of this fraction. And now this matches up our formula really nicely. Okay? Again, the value that is used here with pi over 6, if you were asked to evaluate, you could plug it in right away. It's not going to be the nicest with root 3 over 3 in all those places. You'd have to simplify that fraction, but it could be done. If I use the formula, now that I have this, I can say this is equal to negative tan of 2 times alpha, which is pi over 6. 2 times pi over 6 is pi over 3. And that's equal to negative root 3. Questions you can do for practice are 4, 5, and 6.